and welcome to another episode of FooBar. Today we are going to talk about GraphQL, AppSync, and ask ourselves, are REST API still a thing? If you want to know more about serverless cloud computing or software engineering practices in general, subscribe to my channel in the red button below. I post videos every week. So let's get started. This is another episode in my series of interviews. This is not a podcast. And today I have an amazing guest, Yan Cui. He is a serverless hero, host of an amazing podcast called Real World Serverless. He's also author of many courses, and I'm pretty sure you have read his blog posts. They're always mind-blowing. We started a conversation chatting with Yan about GraphQL and AppSync, and he's making a course about this, so he's coming with a lot of amazing information. But we end in a very interesting way with a very philosophical discussion about if REST is still a valid thing. So watch the whole interview to understand how we got to that conclusion, and I think it's a pretty interesting thoughts. Let me know in the comments, what are your thoughts? Are REST still a thing? So let's get to the interview. Welcome. How are you doing?
Yeah, I'm good. Thanks for having me. Yes, I hope you guys had a good break as well over Christmas and the New Year.
Yeah, I'm super happy that you're here. I will be putting my camera in and out because I'm in a new space with a very bad internet connection. So you will only see Jan today unless my camera decides to work again. So sorry for that. But let's start chatting a little bit about the topic of the day, that is AppSync. So my first question for you is, what is AppSync and GraphQL? Maybe we can start even from one step back. What is GraphQL and why it's so interesting?
Right. Yeah, sure. So I guess the GraphQL was what created at Facebook. I forgot when that was now. Must be 2014, 15 kind of time frame, I guess.
People can check in the Wikipedia, don't worry about when, but it's been there for quite a while.
Yeah, for a while. And it's basically a way for you to, I guess, to how we've you're building your production service with lots of different services, and I guess when you got a company the size of Facebook, you have maybe hundreds, maybe even thousands of different services. So when you're building a front-end application, it's kind of a bit of a pain to trying to remember that, okay, when I want to fetch a user, I need to go to this user API. When I want to fetch his friend, I need to go to another API, and then another API for get the images. And so just those are different things you have to, I guess, coordinate from the front end. You've got this what is called the N+1 request problem, whereby to render a front end, I need to get the list of say your friends, and then need to get some call another API request to hydrate the data I got back, and then I need to make another request to get something else as well, because the API themselves are not designed specifically for the front end. So they are they manage their own sort of, I guess, the bounded context, a specific domain, but then in the front end, that's where everything kind of comes together, which means it's kind of quite inefficient. And on the front end, there's a lot of stitching together different data points from different APIs, and also you're getting get back all these different data points that you probably don't care about. I want something from the user, but I just want the first name, last name, maybe the image URL to show his profile image. But that's it. But then the backend is going to always return me, this whole document, a JSON document full of things I don't really care about, or I don't need to display in a particular page in the front end. So
then you can even have some organizations I work, they even create APIs for all these different views, but then you have so many APIs that it's impossible to know which one is the right, how to update those, how to maintain those. So no matter if you do the full big JSON or you do multiple APIs, it's still a mess.
Yeah, so you've got this whole backend for front end, or BFF, became like a really popular pattern, whereby every team that owns the front end page, they end up having to write their own backend to do all the stitching, to do all the API requests, and then return back just what the front end needs. which means that you got, like you said, every team that owns a different front end page have to have their own BFF. And then when there's some contract changes on the back end, everyone's got updates, or there's a new field, or any kind of API change. Is just a really big blast radius where everybody have to do the same thing. And also, you're creating this maintenance overhead for every team that just want to build a front end page. Now they have to maintain and run some back end as well. So there's a lot of that competency you have to creep in, where you have to think about, when you're building a service, you have to think about scalability, you got to think about the resilience, you got to think about security, logging, monitoring, all that shebang, and being on call for services when Christmas Eve, everyone's checking the Facebook status page,
No.
crashing the site and stuff like that. So GraphQL became like a way, I guess, became a nice way for you to just say, here's all the different data types of data we have in the system and how they're connected together, so that from the front end you can just make one query to get, please get me the friends, and for a friend I want to get back his first name, last name, profile image, and then maybe his interests, and that interest is another list of things which is coming from a different API. But I can then get the information about the interest. If it's like a music, what's the name of the band? What was the profile image, debut album, all this other stuff. Anything that I need to show and render this single page to show this list of friends. So I can make one API call, and then the something is going to be able to then translate that into God knows how many requests to different APIs. But that becomes a problem that the team that owns that GraphQL API is responsible for. And when the backend updates the schema, there's only one place that people need to update. And
I think the schema is a very interesting thing, because I like that strongly type thing that the schema provide, because then when you have the JSONs, you really, like in a REST API, you really never know what it can contain. You don't know if it's a string or if it's an integer. You don't know what is the name across the different APIs. It can be a similar, like name can be name, sometimes it can be person, sometimes it can be whatever identifier, and you're like, but it's name. So conventions for attributes are always like depending who created the API. So I really like the schema because it organizes everything, and it creates my first experience with GraphQL was working in a customer where we have, I don't know, like 16 different types of clients. We were working with smart TVs. So basically every smart TV has their own way of doing things. And GraphQL really helped us, because then we were able to have this schema and then call different consultancy companies and say, okay, this is the schema and these are the views we need. Figure it out. And it was great because we didn't know all the languages of the smart TVs, and they didn't need to know a lot of internal implementation on how the backend was done. They just needed to know what we wanted to achieve and what they have available.
Yeah. And the nice thing about the whole schema, like I said, is type checked, which means you don't have to do any custom request validation, and which is something that you can do yourself, or if you're using something like API Gateway, you could just upload your request model and have API Gateway do the request validation for you. But also what's important is that you don't have to do response validation, which is something that the API Gateway doesn't even do. So with API Gateway, you can attach your response model, but that just goes into the documentation that gets generated from API Gateway. It doesn't actually do any validation against the data you send back from, say, a Lambda function through API Gateway. So a lot of the data exfiltration attacks we've seen in the past, where people steal information from your database by doing some SQL injection attack and do a
Mm.
select star from whatever every table. Those sort of things, just you can prevent a lot of them in terms of actually returning data that the attacker is trying to get, because the schema on your GraphQL API just says well, all you can return is a string. What are you trying to do to return this massive array of things? So you don't have to do any response validation yourself. It's all kind of built into the how GraphQL works. So that's another thing that I find makes life a lot easier. It's just that request response, it just becomes like built into how GraphQL and AppSync work, so that you don't have to don't have to worry about that yourself in your code, which saves me a lot of the boilerplate that I used to have to write when I'm using API Gateway and building the REST APIs.
Yeah, not knowing if you are getting a string or an integer, I think that's kind of very confusing when you're working with API Gateway or any REST API. Like, oh, it failed. Why? Oh, I didn't validate all my inputs.
Exactly.
How many
Yeah.
times that happened? Like, you are sure that the age will be always an integer, but somebody calling the API might not agree.
Yeah. Exactly. And you have to do the validation somewhere. And if you do it with API Gateways, the request model, then at least you don't pay for invalid requests.
Yeah,
but at the
exactly.
same time, the user is going to get back some just random error, whereas they have to figure out, okay, what am I doing wrong? Whereas with GraphQL and AppSync, you're actually going to get back an error message that tells you that, oh yeah, this you're missing some input, or you're sending the input for I don't know, first name as you're sending integer instead of a string or something like that. So that's a human readable and understandable error message on top of all the request and response validation you get.
Yeah. One thing of GraphQL that I was very confused when I started it, and I got the feeling that people are still very confused with it, is that they think GraphQL is like a database or like a thing like that. And when you start reading about GraphQL, you realize it's just a specification. It's not even like an implementation on how to do things. So I think that's always a little bit confusing when people are like talking about GraphQL, and they're like, yeah, it should be like kind of a database or a system application, but it's still just a specification that different companies either implement with libraries like Apollo or things like that, or then like AppSync, and maybe that's our segue into what is AppSync.
Yeah, sure. So yeah, like I said, the GraphQL consists of a spec that defines your API, like your API spec. That's your GraphQL schema. But then something needs to host that schema, and that's the GraphQL server. You can host your own. You can run I don't know, EC2 server or container that's running Apollo server or something like that, or you can run Apollo server inside a Lambda function. We see a lot of people do that. Cloud Guru, for example, they still do that, and I work with some customers who are doing that as well. Or you can use AppSync, which kind of just running and manage the GraphQL server for you, and you just and also the other thing with GraphQL is that you've got a server that can interpret the schema at the request and understand and check the request against the schema. And then when you ask for, say, get me the list of users, it needs to know how do you get that, right? So you still have some configuration to say when for GraphQL, maybe I can switch over to screen share and then just show you what that looks like. So this is, I guess, so this is coming. This is what I have right now for the AppSync Masterclass, which is a video course I've published that shows that teach you how to build GraphQL APIs with AppSync, Lambda, DynamDB, and so on, and by
It's
building a
already available for people to go and get more information.
Yeah, if you go to appsyncmasterclass.com, you can sign up already. It's in early access, so you get a nice discount. But the content is still not complete. Right now we've got a complete implementation for the backend, and Gerard Sans, who was in the AWS team for Amplify as a developer advocate. He's left there now, but he's also working with me on doing the front end, so that he's building the lessons for the front end, so that you have a Twitter clone that kind of looks like Twitter. Doesn't have all the features, but yeah, it's in progress. So
the link is in the description box. So if you want to go and check it out, check the description box and you will be following the link to the course, because I think it's going to be amazing, like on-Chang courses. You have quite many out there already.
yeah, so we have like 11 hours of content already that basically
Wow.
build the entire backend for the well, what you see here. So this is what you see here is the GraphQL schema, where you start at the top by saying with this schema we support two different type of operations. Query is how you get data. Mutation is how you modify data. So in this case, this is where you start by defining a type. So
Yeah,
this is the name of the attribute. This
think
is a
at
type.
least how I like to call them is like queries are operations without side effects, and mutations, they have side effects. And that's how GraphQL separates them. And I think
Yep.
there is subscriptions as well. That's the third one that GraphQL has.
Yep, subscriptions is interesting. It allows you to build like a real-time application with a server being able to push updates to the front end. And the difference between, I guess, the API gateway, WebSocket, and AppSync subscriptions is, I guess, a couple of different things. One is that with WebSocket on API gateway is really quite a low-level construct where you have to manage the socket connection yourself. Where with AppSync is all fully managed. And the way it works is that you say, I want to subscribe to this subscription endpoint. You can also do the filtering as well, which is all controlled by the client that's calling to say, I want to get updates for I don't know, my messages. So if I receive any more direct messages, then I should receive a push notifications through this WebSocket connection. So it's much easier to work with compared to API Gateway, and also you get a lot of things out of the box, like the filtering of messages and things like that. But let's
that's
maybe
one of the powerful features, I think, from GraphQL if you are building applications that real time, because it's so easy.
Definitely, it makes it makes those building those real-time applications really much simpler compared to what it used to take to build those kind of systems. And also
I think
the AppSync subscriptions that when they first launched it, it was running on top of IoT core, which has got WebSocket support, but then it's got some scalability limitations. So I guess what we have right now is kind of the V2 of subscriptions on AppSync, and that's all built on top of raw WebSocket connections, and they solve a lot of the scaling issues that they had in the past. Now you can have millions of concurrent connections to your GraphQL subscription endpoint, and it scales absolutely fine. I think when they did the launch, they did a big test and they had scale to 10 million connections, and it was absolutely fine. It was great. It was awesome.
Yeah, I think from AppSync also a feature I like a lot, if the offline, that's not, you don't need to define it in your query and mutations. I think that's more on the implementation and how they do the conflict resolution on when
So you're
for
talking
example,
about the offline data store, the amplified data store, right?
well, I think it's a part of the AppSync and Amplify together, but the conflict resolution on the GraphQL. So, for example, if you and me both are working on the same document and I'm offline and you did some changes, when I go online, there is an automated conflict resolution. That means that the developer doesn't need to worry too much unless there is something very weird, that you can even implement it yourself. So I think that type of features are really nice when you're working with third party, like client applications, because that happens quite often, that people are, once you have offline support.
Yeah, so that one is actually quite difficult to set up by hand unless you use Amplify. So I think me and Gerard spent a bit of time looking into that, and Gerard, even though he works in the Amplify team, basically concluded that well, unless you use Amplify to set everything up, this is going to be really difficult to kind of to replicate yourself. Like what I have here is using.
Nice.
Sorry.
With Amplify, it's super nice because you use the data store.
Yeah, with Amplify, if you use the data store, it kind of just all built in. But if you want to if you don't want to use Amplify and you want to configure the AppSync API endpoint yourself, like what I have done here using the serverless framework and the serverless AppSync plugin, then it's actually quite difficult to do it yourself, because there's a lot of magic that's in the in how Amplify also set up the data store on the client side. So there's a lot of like subscriptions and everything, like the conflict resolution and all that stuff. That's all just kind of magic that the Amplify does for you. And if you want to replicate that yourself, is by just picking up the right bit of the dependencies. It's well, we couldn't figure out how to do it, basically.
That's for the last part of your course. Yeah. So continue with the queries and your mutations, because I go out of topic very easy.
Sure. So I mean, this is a GraphQL schema where, like we said, we define at the top level the different top level operations you can do: queries, mutations, and subscriptions. And the queries you can. I mean, this is example whereby you can make a query, and then this is the arguments that you expect on the schema, and the way there's a bang means that this is a required argument. So you can easily say, okay, I want to get my timeline, but you have to specify how many pages, how many tweets you want to get in one page of results, and then the next token is for pagination, and this is not required. So the first page, this would be no, and then you can say what response gets sent back. You can also say whether or not that response is required, is nullable or not. So this is not nullable. And if you look at the definition for this as well, you can see that you can return an array, and within that array you can return something that's an interface, which means you can also return, in this case, an array of tweets that is a tweet or a reply or a retweet, all of which implement this interface, which defines a minimum subset of the fields that all of the different types of tweets that you can get back have to implement. But for different type, you can also have different properties. So some stuff is only on the reply, whereby you say the tweet that you're replying to and the users you're replying to, for retweets, you have a retweet of the original tweet that was retweeted, and so on. So there's a lot of things you can actually just specify and capture in your type in your schema, so that they at runtime they'll all be type checked. And so for each of these fields, you have to hook it up to say, when someone makes a request to get my profile, what happens? And that's where you have to define your resolvers. So if I look at the definition for this, whereby in here I'm saying the request is a query to get my profile. So the data source is.
Maybe you can talk a little bit about what you're showing, because maybe a lot of people are not familiar with what is this document. Because
okay, right. So this is I'm using the serverless framework, and so in the serverless framework here, I've defined a bunch of DB tables and the cognitive user pool and so on, as well as some Lambda functions that does very different things.
It's a plugin for the serverless framework.
Yeah, the serverless AppSync plugin. So using the serverless AppSync plugin, I'm able to then also configure my entire AppSync API using the serverless framework, in this case, by putting all my definitions for an AppSync API into a separate YAML file, whereby I'm saying the name of the API is going to be AppSync master class. What's the name of the schema, which is schema.api.graphql, which is in the root of the project. And then also I can configure what authentication type you want to use for this AppSync API. And I'm saying it's going to be using cognitive user pool. And so this is basically the definition for my AppSync API, all in this one YAML file. And the key thing here is really the mapping templates. So for every operation you have, every sort of field and type you have, you can define the who is responsible for handling this request, this query request to fetch a user's profile. And then you can also say on a particular type, for example, on, let's see, my profile. When someone returns my profile, or maybe a good one would be other people's profile. So this is something I like to do as well, in terms of security, that I don't want you to, for example, if there are information that only I want to return only when the user fetches his own profile, so that other people sees him publicly, he will have a different public profile that doesn't contain, for example, birth date, for example. Not applicable here because both profiles have this birth date. But imagine if I only want to return someone's birth date, if when he sees his own profile, but when someone sees his profile, like you see a public version of the profile which has got some information like birth date and other things has been I guess
your address, your phone number, I don't know.
Yeah. Any sort of sensitive information that you don't want to return to publicly, then you can also do that by making sure that the only time you return my profile is when the user calls his own profile, and notice, I guess, calls get my profile, and notice that there is no argument here. It's an empty argument. And so the only way that we know to get which profile to fetch is based on your identity. Since in this case, we're using Cognito. So every request has to be authenticated by Cognito. So user have to sign into Cognito first. And when they make the request, when they sign with Cognito, they're gonna get back a Java web token. JavaScript web token, JWT token. And that token gets sent to the backend when you make this request. So when the AppSync receives this request, it's already been validated. It's going to validate it with Cognito to make sure that this is a valid request from a user. But most importantly, when we say, okay, now we've validated this request, we need to run something to fetch data from somewhere. So that's where you have this mapping, whereby we map this get my profile operation on the query type. So you see type query, the field is get my profile. We map it to a data source, and in this case, the data source is a DynamoDB table that we've defined in this document here.
What data sources are supported with AppSync? You mentioned Dynamo. What else?
DynamoDB, Elasticsearch, Aurora Serverless, Lambda, and any HTTP endpoint, which you can basically means that means you can use AppSync to call any AWS service through HTTP, because all these AWS services have got the REST APIs you can call, so you can use the HTTP resolver to call internal APIs. If you got a bunch of microservices, you want to put a GraphQL in front of that, then you can basically define your schema for all the different types of data you return, like this. And then behind it, you map, say, get my profile to a HTTP request to some internal API you have, but that's running REST. So in this case, you can then have I guess the first step of your migration to GraphQL, or instead of building the custom BFFs everywhere, you have just AppSync integrating your internal REST APIs with HTTP. You can do the same thing with AppSync with, say, SQS or SNS or step functions by calling those REST endpoints for those services with HTTP. But most likely, you're going to be using things like DynamoDB and the Lambda and maybe Elasticsearch.
I think the use case directly from AppSync to Lambda to anything is like a quite normal use case, because Lambda is so easy to integrate to anything inside AWS.
Yeah, absolutely. Yeah, and also with things that's outside of AWS as well. So, for example, for this course, I'm going to be using Algolia as for search, which is probably the closest thing you have to a serverless Elasticsearch right now. Amazon Elasticsearch is still not serverless. You have to run servers, you have to pay for uptime and all that. With Algolia, you don't have to worry about that. It's a SaaS, and you just pay for I guess units of a request, or I guess they charge you in units, which is basically a certain amount of requests per month you can make, as well as a certain amount of data you can store in the system, in their system. So, but it's this closest thing we have to serverless Elasticsearch right now.
Yeah.
And to integrate with that, I use Lambda to do that.
Yeah, so you create the right request for Argolia and then
Yeah, absolutely. So in this case, we say for this operation, where the data is coming from, but we still have to define how do we then make a queries to this DB table? Do we do a get? Do we do a query, a scan, or whatnot? And that's whereby by default, you can also specify the request and response template, which are basically ETL templates. And if I don't specify them here, then it uses a default whereby it follows the naming convention of the type
oh,
followed
nice.
by the field. So I can do things like do a request. So in this case, when that operation comes in, it's gonna do a get item request against DB, that users table where the key is ID, and then it's gonna take the user's username, which is has been resolved by Cognito. This is user's username, like user ID, which would be like a GUID. So in this case, we don't ever want someone to be able to fetch somebody else's profile with this operation. So it's always coming from, it's always based on, the ID is always based on your identity as opposed to an argument.
Yeah, and all this information about the context dot things you can find in the documentation of BTL and AppSync, what is available, because there is quite a lot of interesting things in there. And one of the username, for example, that you can play around and use in different types of your application.
Yeah, with the context, you get things like the actual request. What was the request? You get information about what fields is someone trying to select. For example, when the user makes when a client calls a request to say get my profile, the request is going to look something like this. You got a query, and then you have the operation get my profile, and then you also specify in the results what fields from my profile type do I actually want. Maybe I just want ID, maybe I want first name, and maybe I want birth date, for example. So you can the caller can decide what of the fields from this type do they actually want to be included in the response, which solves another problem that REST often have, is which the backend just returns everything all the time. So now the client can control what information comes back from the rest from the backend, and this selection of fields is also available from the context object as well. You can use here, which means there are some cases whereby you can make a small optimization. For example, if say someone calls to get my profile and all they want is the ID, and we know for a fact that the ID is actually just your username. So rather than making a request to DynamDB just to get and then to just return the ID, which seems a bit silly because we already have that information, you can make a short circuit to say, check in the context and see what fields are being selected by the caller. If you just ask for ID, then just return context.identity.username.
And that's the power of BTL. It's a full language. It has loops, it has if, it has a lot of different things. So I think, at least when I was getting started with AppSync, I think it's spending a little time with BTL. It's a great way because it's kind of free execution. Because you could run Lambda here, but kind of this is for free.
It's just unfortunate that the BTL is probably not the most user-friendly language. Well,
I don't know. Now there is login in AppSync, but when I got started, there was no way to see how things were failing. You were really blind.
Yeah, so nowadays with AppSync, you can actually enable resolver logging, detailed the resolver logging, which can actually show you for every operation what was the request and what was the response, and if there are multiple steps in the invocation. Maybe an example would be, okay, let's go through this simple example first. So we've mapped this get my profile request to a request to DynamDB that gets executed against the users table in DynamDB, and then there's also by default by the convention is look for a response to VTL template. The name is followed by the request, so the type, the field dot response dot VTL. So in this case, what we're doing is just using a built-in util, I guess, object in AppSync that contains a bunch of things like, converting JSON, from and to, and a bunch of other things like that, to just say take the result from the DynamoDB request and just turn it and return it as a JSON. That's it. This is probably the most often used response template. Most cases, that's all you have to do. And in this case, that's it. That's a very simple request that we support in this GraphQL API, and there's no Lambda function involved, like I said, which means it's very fast. There's no cold start. There's no extra cost for invoking a Lambda function as well. So
it's only a request to Dynamo, basically.
Yeah, so there's still request to Dynamo, but again, if you want to sort of cut out some of these requests to DynamoDB for things that, for example, maybe a lot of people are trying to fetch, popular users by screen name, and the user's profile doesn't really change. So you want to enable caching. So you can also configure caching for per resolver. So in this case, every single request, you can cache at a whole request level, or you can cache at a per resolver level, which is great for cases whereby, for example, maybe I want to return. Let's see, this is. Don't really have a good example in here, I suppose. But imagine if we want to return something whereby I'm trying to think of example. A good example would be another project I've been working on, which you can see here, whereby we have universities. We return the sports, and for a user's profile, you have a list of let's see, sports, maybe public profile. So this is a actual real life project, so it's a bit more complicated. It's got a lot more things. So I think it's I'm looking for public profile. Yes. So for example, when you fetch someone's public profile, you can find out what university that user belongs to, and the list of profiles that he or she does. So even though you may not want to cache the entire profile object, but the universities, I mean, lots of people belong to the university. There's no point us fetching this university on every single request. So you can also just cache just the university information, or just the information about individual sports, so that you can be really granular in terms of what bits of a request of a response, of a request gets cached, so that you can cut out a lot of the unnecessary requests to DynamoDB. For this project, I spent quite a bit of time just tuning the caching, what gets cached and what doesn't, and we're able to get a consistent 99% cache hit rate, which means that 99% of requests to DynamoDB just never goes to DynamoDB. It just goes through the cache. So we're able to keep the DynamoDB and the Lambda cost really low because of that. Even though there was a decent amount of requests at the time.
Cache is managed by AppSync.
That's right. Yeah. So that the caching is all done with managed by AppSync. We just have to say the size of the cache node that we want to use. Which the smallest one I think you can use is got about 1 point something gig of memory, which or maybe less than that, maybe it's 512, maybe I can't remember now. But even the smallest one was plenty, had plenty of memory for what we were doing. And when we first launched, we had about 250,000 requests per day, and for the first month, our AWS bill was like $60 in total, and $35 of that was for AppSync caching. DynamoDB was like $4 or something silly like that. Lambda was $0 because most of the invocations got just doesn't happen because. Yeah. So it was in a free tier. So even though that project has quite a few Lambda functions that will do different things, but caching was so good that you just cut out most of your cost with the good caching strategy.
Pricing. I just think about this question that is not relevant to the schemas and things like that. But I'm just curious now. You have quite a lot of experience with serverless. What about the comparison with API Gateway? Because that's one of the most expensive things in your serverless kind of projects and AppSync? How different is the price?
So in terms of pricing wise, AppSync is actually more expensive than API Gateway per unit. So API Gateway REST APIs is $350 per million requests. AppSync is about $4 or $4.50. I can't remember, maybe it was five. I don't remember the exact number. But the thing to keep in mind is that it's not a like-for-like comparison because of the fact that with REST APIs you have that N+1 request problem. So a user request may end up being 4 different API requests to REST endpoints, which means you are going to be paying for 4 of those, plus any Lambda invocations that happens behind the scenes. You have to pay for those as well as any database access you need to make, DynamoDB requests and so on. Whereas with AppSync, it's one request. By all means, it could be just one request to fetch my profile or to get my timeline, which behind the scenes, it might require multiple requests to DynamoDB to get all the necessary data, but then it's one request from API Gateway. You pay for, so AppSync charges you in terms of the number of requests it handles. So in this case, it's one request. But if it has to make 4 different DynamoDB requests behind the scenes, then you pay for that 4. But you don't need to have Lambda here, which means you don't pay for the Lambda invocations. And also from the user experience point of view, you don't have to pay for cold starts and the actual execution time for Lambda function because it's all done in VTL for this particular request. So with the DynamoDB cost, it's kind of equal on the REST and GraphQL, but then you cut out a lot of REST API requests as well as Lambda invocations in terms of your cost. So I suspect for a lot of the real world projects, you will probably find that your REST API, so your AppSync API, to be cheaper than to do the equivalent with REST and API Gateway and Lambda.
Yeah, and I think it comes with so many things out of the box that might also help you out with the Cognito integrations and all the authentication things and authorization level granularity that it provides.
So with that, let's talk about group-based authentication. So for this project, we have the mobile facing API. I can see that some operations can be accessed by both the backend using API key, or we can change this to AWS IAM, as well as by the front end using Cognito. But we also have a CMS system, which supports users from different that's got different roles. You've got admins that can do pretty much everything. You've got universities. You've got admins that can do everything, and then you have associations, which is a special group of users that can only do a very small subset of things, but then you have universities who can administer their own university, like configure the what sports program they offer and things like that. And with API Gateway, if you want to do this group-based authentication with Cognito, it's actually quite awkward. You have to use Cognito, which supports groups, but then you still need to have a custom Lambda authorizer because they're not tightly integrated, so that you still have to have the Lambda authorizer basically inspect for a caller what groups that caller belongs to, extract the IAM, the role ARN from each of those groups, and then based on the precedence value you set against each of the Cognito groups to decide what IAM roles should be used, and therefore use that to generate the correct principle and policy and return to API Gateway. And that's how you can do group-based authentication with API Gateway. Alternatively, actually more and more people now just do it themselves. Don't use Cognito groups, and then just set up those groups in the DynamoDB and have a mapping between groups and the policy, and then you just return a policy. But in any case, it requires you to write a custom Lambda authorizer. There's a lot of boilerplate code you have to write to make that happen. With AppSync, this is all you need.
Wow.
Like online.
Basically, you're mentioning for each operation which groups can do it.
That's right. And you can also apply that to the different types you have as well, so that you can say what types each operation, both the mutations as well as the queries, which groups can access them. And you can also, I think show you one whereby you can say multiple groups can access this. I think that was one. There you go.
There.
Yeah, multiple groups can access this operation. Can access this operation. So it's all built in.
Think then everybody can do it.
Yeah, that's right. If you don't have anything, so if this is blank, then everyone can access it.
So simple.
But it's just so straightforward. It just, I mean, one of the reasons why I used the AppSync for another project was because of we have to do a lot of the HIPAA compliance stuff, including group-based authentication and all of that, and the request response validation, yeah, this. So we basically did a look, and we started with API Gateway and REST, and then we had a look and realized that it's going to take us like a week to do some of these things, like group-based authentication and a basic request response validation, plus the schema documentation. At least a week for 2 people, and 2 really experienced serverless developer. Well, I guess application developers, myself and a friend of mine, and then we just thought, how much would it take to just rewrite everything, just dump everything we have and get back to where we are now, plus group-based authentication and the request response validation? It took me like half a day.
Wow.
So just basically recover all the lost, I guess, progress we made, and then implement group-based authentication plus request response validation, because that's just the things that you get out of the box with AppSync and GraphQL. So yeah, sometimes the amount you get out of the box is just crazy how much you get done. So like this whole project, this is I did a blog post on this a few months back, I guess. I built this whole project, the first version of this whole project, in a couple of weeks myself, working part-time. It's crazy productive stack. AppSync, Lambda, DynamoDB, Cognito. It's just so productive.
I think one question now, maybe people that are watching this are wondering when you will use a REST API.
Yeah, that's a good question. I think for a lot of things that's you're doing for internal APIs, you probably don't need to have, REST API can still, it's probably more than enough. If you're doing like, in your traditional, well, maybe not traditional is the right word, but in your like the microservices architecture, you have lots of user-facing endpoints, but at the same time, you also have lots of internal endpoints that are only used by internal services, and they don't really need to be stitched together in the same way as those user-facing APIs. And for those, I think those are perfectly fine to stay as REST, because the access patterns are fairly stable. There's not as much experimentation that happens with those endpoints, and also those endpoints often tend to be probably more siloed as opposed to the stuff that are user facing, where they're often connected to other things, like a profile is connected to I don't know, a sports that someone's doing, or university that someone belongs to. So there's less. I find there's less of that, the sort of stitching things together when it comes to internal APIs. And so
Can
for internal APIs.
For this question. So if we were thinking of a serverless architecture, most of our services inside our microservices, inside of our they will be event driven. Does it make sense at all to have REST APIs, or should we use event bus and then send events through there and then have AppSync?
Yeah, so that's another good question. So when you have different microservices that need to access each other's data, you can also, you can either make a API call to another service, a REST endpoint, to say, get me the data for X, or potentially what you can do and this is the approach I prefer, is when every service updates some data, they will publish that as an event to some event bus or some stream somewhere, so that the other microservices that are interested in this data can then just listen to those changes and then take a copy of what they need, which means that at runtime, service A and service B, they will be completely independent of each other. So if the service where the data I'm interested in is normally sits, if it's down, if at runtime I have to make a request to service B, I'm service A, by the way, I need to make a request to service B to get some data, then that means I won't be able to handle my request because service B is down. But if you look at the event-driven approach, whereby I'm always listening to events from service B for, I don't know, maybe like service B is an order processing service. So it's publishing events whenever a user places an order, whenever the order has been processed. So if I'm listening to those events and I'm keeping a copy of the data that I'm interested in my own database, which means whenever I need to handle a user request for my service, maybe it's to check promo codes or something like that, I don't know, I don't have to call service B. I can check with my own database and have if everything is working, then I have a relatively fresh copy of the most recent data, which means if service B is down in production, my service is still up and running. And it's a really good way for you to build a more resilient system whereby you don't have those what we call cascade failures in the system, whereby one service goes down, everybody else follows because everyone have to kind of make a request to other APIs, and then all the way or they will end up calling this old API for data.
And exactly, and that's where my question are REST APIs still a thing? It's a weird question, maybe, but just thinking it from our client applications are really good with GraphQL, and our internal applications are really event-driven. Do we really need them?
It still depends. I mean, that's like that. I think that's how you should be building things by default, but not everything can be done like that. And certainly, I've seen lots of examples of people that are moving to serverless and to I guess new styles architecture that's so evolving around events. Not everything fits into that box, and sometimes you do have to have something own the entire thing. For example, there may be data that's just too big to be copied everywhere. If you think about Facebook as an example, there may be an API that holds the relationships for different users. The query that you need to make against that is requires a very specific handling, and the amount of data you have in that system is also so big that if you need to copy everywhere, then you're going to be essentially multiplying the cost for storage for that particular set of data, which is probably the biggest amount of data you have in maybe the whole of Facebook, I don't know, everywhere, which means your storage costs in total start to look really unfavorably for having this approach of of duplicating data. And the way you need to query that data is not simple, just get. It probably involves a more complicated query patterns that uses very more specialized databases and things like that, which then becomes operational overhead that you don't want everyone to have to deal with and have to understand. So that is a good example for something that the access pattern or the storage mechanism is sufficiently complicated and maybe costly that you don't want to be duplicating that data or or use that particular database for in every single service. It's there's always going to be some cases where this model doesn't quite fit, but for a lot of the basic basic data that you just want to do simple lookup by key and things like that, then absolutely copy the data everywhere. Another example where you probably don't want to do this is if you got things like a user PII information.
You don't want to copy the data.
Yeah, if you copy that everywhere, then things like GDPR becomes really difficult for you to actually to comply. Where someone says, I want to delete my data, well, good luck, because that data is copied in every single microservice. So there are cases where that model just doesn't quite fit. So you probably
APIs are these things that I think backend developers use as default. So I think with this discussion, we basically came to the conclusion that yes, sure, they have a space, but like EC2 instances have a space. Now they are not like the first response to our solutions. Maybe we got with something else, events first, and then if we really need them, we put these things in place.
So I guess like I said, it's gone from the default to only when you have this case.
Exactly. So that's where I want to kind of end, I think, the discussion, because I think we can speak for hours about this thing. but I think it was an unexpected kind of conclusion that at least I was not planning to reach today. I don't know about you, but I was not planning to get there.
It's good that we got here though. That's
Yeah,
something that I get asked a lot. Like when will I still use REST, and why?
I get it all the time. And the more I get it, sometimes it's very hard to really think when you will use it. I still think it's really great for synchronous use cases when you have an API that it just needs to be simple enough. And I think now with the express step functions, the 1 millisecond billing, and API gateway, you can get some very powerful APIs that are still having a place there. But I still totally with you with the event driven and with AppSync as much as possible. So it becomes harder and harder to think about architectures with API gateway for me.
Yeah, I do find myself doing. I guess of all the recent projects I've been working on, I've kind of all defaults to AppSync because it's just so simple, and also because I guess most of the APIs is just client-facing stuff. It's just so much easier to do, client-facing APIs with GraphQL and AppSync, and compared to compared to REST, the amount of workload just night and day, just doesn't compare.
And more if you're using Amplify, then that becomes super simple to use. Kind of this combo, no? But
Yeah, I don't actually use Amplify. I think Amplify probably automates a bit too much, and I think Amplify probably not really. I'm probably not the right target audience for Amplify because no, I'm more of a sort of backend dev, and I do like to have a bit more control over what resources are provisioned, how they're provisioned, and be able to sort of customize things if I need to. But I think Amplify is quite useful as a reference, whereby sometimes I wonder, like with Cognito, like how do I set it up so for like social sign-in and stuff like that? I can just run Amplify, and then the Amplify provision the resources, and then I take a look at the template, and then I just copy the bits I need.
that type of functionality, at least in some, it will be
Right.
lovely to see something like Amplify for the backend of AppSync, like just that bit in the some maybe, or in some easier CDK, or I don't know, somewhere where you can, like serverless framework has this plugin, but it will be
Yeah.
really nice to see from the AWS offering that if you're using
I
CDK
think
or something that can make those things happen. So that's
I
on my
think
wish list.
CDK supports AppSync. I've seen people use AppSync with a CDK, and they seem quite happy with that. But I don't know
Try it.
about SAM. I haven't tried it myself.
Some you
But
need
the
to
thing,
end up with the cloud formation definition, so it's not as
yeah,
nice
yeah.
as a plugin. So
Yeah, the plugin makes life a bit easier because AppSync still requires a lot of resources. Not maybe not quite as crazy as API Gateway, which is just so much resources.
yeah, but it's nice to define your data sources all together,
Oh
and
yeah,
if
true.
you're using Cognito, the Cognito user pool, like everything in the same infrastructure stack. At least that's something I like to do. So
Yeah,
defining everything as cloud formation is painful. That's what I
yeah,
like,
it is.
Sam.
Yeah,
But
I
it's
think I don't think Sam supports AppSync yet, does it? At least I haven't seen one.
not yet. I hope they
Okay,
do it eventually. They
okay,
added step functions last year, so I hope AppSync
okay.
is in the list. I don't know, but it's something I've been asking, like an easy
Yeah,
way to do. Like they do API gateway, it's so easy, and like I would love to see the same for AppSync, because as
yeah.
we were discussing, uh, GraphQL is the new black, at least for your client calls.
It's a new normal.
But yeah, I think with this we can wrap up, because as I was saying, we can talk for hours about this topic. I think it's something you are really passionate about. I really love this topic as well, so we can have a discussion for the whole night. But yeah, I want to thank you for your time, and I think if people want us to discuss more, just let us know in the comments or give like to this video, and if I see that there is a lot of kind of calling from the audience, then we can set another call and have a more deep discussion on AppSync and GraphQL and what is the future of these things, because I know we
Sure,
can speak a
sure.
lot about it.
Yeah, I'm always happy to talk about the serverless and the AppSync and GraphQL and stuff.
Yeah, me too. So, and I love talking with you because you know so much. So I can
Likewise.
ask you all the questions that. So thank you very much for your time, and I hope this is the second time we record this interview. It's a very different interview than the one we recorded before. So thank you again for spending so much time with me.
No worries. The second time the charm.
Yeah, well, the camera is not working today, so but I have a recording.
At least we got recording
So
this time. So
yeah, exactly. So thank you again, and have a great day.
you too.
Bye-bye.
Take care. Bye bye.
Thank you for watching until the end. This was super fun interview with Yan, and I will be making more interviews in the future, so let me know who you would like me to interview if you have some guests in mind. And if you like this video, give it a like, and you can find all the ways to interact with Yan and find Yan in social media in the description box as always. I see you in the next episode of FooBar. Ciao ciao!